a nuclear reaction. Now let's begin our discussion on nuclear reactions. So what exactly is a nuclear reaction? Well, a nuclear reaction is basically a reaction in which we have two nuclei of atoms that collide with one another, or some type of small particles such as a neutron collides with the nucleus of our atom. Now basically, most nuclear reactions are transmutations, and a transmutation is a reaction in which the parent nucleus transforms into another atom we call the daughter nucleus. Now to see exactly what we mean, let's consider the following nuclear reaction that was first observed by Rutherford. So basically we have an alpha particle that collides with the nucleus of the nitrogen-14 isotope to produce the oxygen atom as well as release a hydrogen atom. So basically this is one type of a nuclear reaction. We have two atoms basically colliding where the alpha particle is basically the helium atom to produce two different atoms. So this is the parent nucleus, this is our daughter nucleus, and these are our two small particles, our two small nuclei. Now, basically, in any nuclear reaction, we have the conservation of energy, the conservation of linear and angular momentum, the conservation of electric charge, and the conservation of nucleon number that is readily observed. So all these conservation laws hold in nuclear reactions. So basically, let's examine if the nucleon number is actually constant. So let's begin with the reactant side. The nucleon number is 4 plus 14 or 18 on the reactant side, and the nucleon number is 17 plus 1 or 18 on the product side. So we see that the law of conservation of nucleon number does in fact hold in our nuclear reaction. Now, just like we can describe the change in energies of the reactants and the products in any reaction, we can also describe the change in energy to take place inside nuclear reactions. Now, if inside our nuclear reaction energy is released as a result, such a reaction is known as an exothermic or an exergic reaction. However, if in our nuclear reaction an energy input is required for that reaction to actually take place, such a nuclear reaction is called the endothermic or endoergic reaction. So basically, the formula or the equation that describes any type of nuclear reaction is given by this equation here. So this is the general equation for nuclear reactions. So we have the reactants collide to form the products. Now on the reactant side, we have the parent nucleus or atom given by X and our small nuclei or particle that collides with that parent nucleus. Now on the product side, we have the daughter nucleus that is formed given by X prime and our small nucleus or particle that is released as a result. Now, as mentioned before, we have the law of conservation of energy that readily holds in any nuclear reaction, and that means we can write the following equation. So basically, on the reactant side, we have the sum of our rest mass energies of our particle A as well as our parent nucleus X. Now, this is equal to the rest mass energies of these two quantities given here plus Q. Now Q can be solved and we get the following result. So Q is equal to, we take these and bring these to the reactant side and we get the following result. Now because we have the C squared term that appear in every one of these quantities, we can take that out and we get the following result. So we take the difference of of the masses and multiply that by c squared, and that gives us our Q value. Now Q is simply the Q value or the reaction energy of our nuclear reaction, and by the conservation of energy we see that Q simply represents the change in kinetic energy that takes place when our nuclear reaction takes place. So Q is simply given by the change in kinetic energy. It's the kinetic energy of the final product minus the kinetic energy of the initial reactants. So we have the kinetic energy of X prime and B. We take the sum and subtract the sum of the kinetic energies of the reactants. So this gives us the reaction energy. So we can either use this reaction, or we can either use this equation or this equation to calculate what the reaction energy is. Now, whenever Q is a positive value, that basically means our nuclear reaction is an exothermic or an exergic reaction. And if Q is positive, that means that the final kinetic energy of our two products is greater than the initial kinetic energy of our two reactants. So that means when the reaction takes place, energy is released, and that energy is gained by the kinetic energy of our two particles, of our nucleus, the daughter nucleus, and particle B. Now, on the other hand, if Q is negative, that basically means that this quantity, the sum of the kinetic energy of the reactants, is greater than the sum of the kinetic energy of our two products. And that means that in order for such a reaction to actually take place, energy must be inputted into our system. And such a reaction is known as an endothermic or an endoergic nuclear reaction.